Good morning, students of grade 8. Today we will continue our lesson about mechanical waves. Today we will start a new idea is about how to find the period or the wavelength graphically. First of all, to remind you, a period is the time needed by the wave to complete one oscillation or one cycle, while the wavelength is the distance covered by the wave in one cycle or one oscillation. So, to find the period graphically, we must work with a figure having a time axis, while to find the wavelength graphically we must work with a figure having a distance axis. First of all, to find the period using this figure, since it contains a time axis, this period must be measured from a crest into a crest, or from a trough into a trough, or from an equilibrium position into another equilibrium position, to ensure that the wave complete one cycle. For an example, to measure the period using this wave, if we start from the point 0, the wave will end up at the point 2. So the period will be 2 minus 0, which is equal to 2 seconds. If we start at the point 1, the wave will end up at the point 3. So the period will be 3 minus 1, which is equal also to 2 seconds. If we start from a crest, this crest is at the time 0.5 seconds. It will end up at the other crest, which is at 2.5 seconds. So the period will be 2.5 minus 0.5, which is always also equal to 2 seconds. If we start from a trough, this trough is at t equal 1.5 seconds. It will end up at the other trough at the 3.5 seconds. If we subtract 3.5 from 1.5, the period will be also 2 seconds. The period is always constant and never change. The other figure allows us to measure the wavelength graphically, since it contains a distance axis. To find this wavelength, we start measuring from a crest into a crest, or from an equilibrium position into another equilibrium position to complete one oscillation. If we start from the point 0, the wave will end up in one complete oscillation at the point 4. So the wavelength will be 4 minus 0, which is equal to 4 centimeter. Or if we start at the point 2, the wave will end up at the point 6, which means that the wavelength will be 6 minus 2, which is also equal to 4 centimeter. If we start at the crest, this crest is at the distance 1 centimeter. The other crest is at the distance 5 centimeter. So the wavelength will be 5 minus 1, which is equal to 4 centimeter.